All right, let's just make sure we're on the same page right here. How many trips around the unit circle have we made? Well, if we start at 0 degrees, we go through the first quadrant here, and then we start heading down in the second quadrant, and then we go into negative numbers in the third quadrant, and in the fourth quadrant we head back up, and right here that is one trip around that we made of the unit circle. So this would be 1, 2 trips. And the question is, how far on the x-axis is each trip? Well, this started at 0 and went to 2 pi, so I guess that would be a distance of 2 pi. If I made another trip over here, that would also be a distance of 2 pi. And hopefully you made those observations. Mathematically, is there anything that would prevent us from continuing in both directions? Mathematically, there's nothing to prevent me from going around in a circle over and over and over again. The only thing that would stop me would be time, or if it was a Ferris wheel, the mechanics of the Ferris wheel. But mathematically and numerically, nothing would prevent me from going this direction or this direction over and over and over again. So why are -1 and 1 the highest and lowest points? The reason is because the radius of our unit circle, is 1. So I go 1 in every direction. That's the furthest I go. What could change that? A bigger circle could change that. Or a smaller circle could change that. Those would be to me, the most obvious things that would change that. Where are we decreasing? Well, we go up here, so we're going up to its highest point, and then we start going down. So from here, we go down, 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 to right here, we stop going down. So this entire interval we are decreasing, which means if I did my average rate of change formula between any 2 points, my secant line, that's pretty steep secant line right there, right? What if I took 2 points like here and here? Well, that secant line would not be as steep, but still they would be decreasing from pi over 2 to 3 pi over 2. That would be a decreasing interval. So where would it be increasing? Well, here's an interval where we're increasing the whole time. Here's another interval where we're increasing the whole time. In quadrant 1 and in quadrant 4, we're increasing the whole time. And how are they similar? Well, they're similar in many ways. They both have the same, they don't go lower than here, they don't go higher than here, both of them. So they have the same lowest and highest points, or maximum and minimum. They both would go on forever in either directions. They both have the same length until they repeat themselves. So we already established that sine from 0 to pi, it goes all the way around the unit circle, and voila, that's one trip around. For cosine, our trip starts right here at the highest point. It goes all the way around the unit circle and then comes back around right here. So that's one trip around. And notice that's the same. Look at this, 2 pi starting at 0. So it's the same length right here. Same length between 0 and 2 pi to make a trip around the unit circle. So that's how they're the same. And then the only way they're different is, well, when I start paying attention, the cosine starts at the highest point, goes all the way down to the lowest, and finishes here. So cosine, this is its shape, where sine starts in the middle, goes up, down, and comes back here. So that's the only difference I see.